In this video, we'll go over LeetCode question number 49, group anagrams. Given an array of strings, we need to group all the anagrams together, and we can return the result in any order. As a reminder, an anagram is a word formed by rearranging the letters of another word. For example, night and thing are anagrams because you can rearrange the letters of one word to form the other. So let's say the input array consists of the strings eat, tea, tan, ate, gnat, and bat. Then the answer we'd have to return would be a 2D array where each inner array groups the anagrams together. So gnat and tan are grouped together because they are anagrams of each other. And the same is true for ate, eat, and tea. And bat is by itself over here because none of the other words are an anagram of bat. So how are we going to identify which words are anagrams of each other? Well, instead of rearranging the letters of each word into every single permutation and seeing if there are any matches, if we can just agree on a common way of arranging the letters of each word, that would save us a lot of time. And so one way we can do this is by sorting the letters of each word in alphabetical order. For example, if we sort the letters of the word ate, it becomes AET. If we sort eat, then that also becomes AET, and the same is true for tea as well. And so since all of these words become the same once they're sorted, we know that they are all anagrams of each other and should be grouped together. The way we're going to keep track of all the different groups is to use a hash table, where the key will be the sorted word, and the value will be an array of all the words that are part of this anagram group. Once we place each word into its appropriate bucket, then all we have to do at the end is return all the hash table values inside of another array. So now let's look at the code and solve this using Python. Let's say the input list consists of the strings tar, rat, cat, and art. The first thing we'll do is create a dictionary called grouped, since it'll keep track of all the grouped anagrams. We'll then iterate over the strings list using a variable called word, so the first word will be tar. The first thing we'll do is sort word, and let's break down this line a bit more. So in Python, the sorted function can be used to sort the characters of a string, and it'll return a sorted list of all the characters. So this would return a list with the letters A, then R, then T. We'll then use the string join method to convert this list back into a string, and whatever string is here will be used as a separator between all the list elements. Right now, this is just an empty string, so in other words, there will be no separator. So after joining each character in the list back into a string, sorted word will be the string art. Now it's time to add our result to the group dictionary. If the sorted word is already a key in the dictionary, then we'll simply append the original word to the list of grouped anagrams. But right now, art is not a key in the dictionary, so let's jump to this else block and we'll create a key of art, and the value will be the original word, tar, inside of a list. Now let's look at the next word, which is rat. Again, we'll sort the characters of this string, and it turns out to also be art. Now when we check this condition, we see that art is a key in the dictionary, so we can simply append the string rat to the existing list that corresponds to the key of art. The next word is cat, which becomes act when sorted. Act is not a key in the dictionary, so let's create that key and initialize its value to a list with the string cat. Finally, the last word is art, which is already in sorted order. Art is a key in the dictionary, so let's append art to this list as well. We're finally done grouping all the anagrams, so all that's left to do is return all the dictionary values using the values method. And this will actually return a dictionary view object, so the last thing we need to do is convert it into a list. And now our final answer will be a 2D list, where the inner lists are the values from our dictionary that groups all the anagrams together. And we're done. Now let's analyze the time complexity. If n is the number of strings in the input array, then this outer loop runs in O of n time, since we need to traverse the entire array. For each string, we'll need to sort the characters. So if m is the maximum length of a string in the array, then this part runs in O of m log m time, since that's the cost of sorting. This join method will run in O of m time, since it needs to traverse the entire sorted array of characters, but it will be overshadowed by the O of m log m cost of sorting, so we can ignore it. Now, what about this line? Well, the nice thing about hash tables is that lookups run in constant time. To be more specific, the amortized complexity of hash table lookups is O of 1. The amortized complexity of appending to a list and adding a new key value pair is also O of 1, so therefore, the overall algorithm runs in O of n times m log m time.